Okay. Now I will talk a little bit about the international system of radiation protection. First of all, I will give an overview about the international organization which are involved in the development of radiation protection. First of all, there is the ICRP, the International Commission on Radiological Protection. The ICRP was founded in 1928. The work was initiated because after the application of ionizing radiation, health effects were observed. At that time, X-rays were used for many things, and the technique was not so far developed to really control all the radiation fields. The ICRP is a charity. This means it is more or less a private organization. And in the beginning, it was mainly the cooperation of medical doctors who were working with ionizing radiation and with X-rays. The tasks of the ICRP are to estimate exposure levels from applications of X-rays and radionuclides in medicine. This means the total dose and also the dose rates. Provide information about the age and gender of the doses. And also looking whether the pathway, external or internal, has an effect on health. And finally, ICRP also developed a system to be able to convert exposure to radiation dose. This means to convert activity intake into a dose. Finally, and this is also a very important point of the ICRP is to provide recommendations for radiation protection. This means to give recommendations about dose limits, about reference levels for specific applications, and to provide the basis for developing radiological protection standards worldwide. However, the ICRP is not working alone. It's working hand in hand since more than 60 years with UNSCEAR, which is the United Nations Scientific Committee on the effect of atomic radiation. UNSCEAR was founded in 1957. It was a consequence of the increasing application of nuclear techniques in the 50s. So therefore it was founded to systematically study the effects of ionizing radiation. And this includes radiation from natural sources, from medical sources, also from the applications of ionizing radiation in science and industry, and importantly also to estimate the levels and the trends of radiation doses to people worldwide for all of these applications. And UNSCEAR publishes regularly reports in which those estimations are given. In addition to that, UNSCEAR works on studies on ionizing radiation, in particular on the effect of humans, and also since about 20 years on the effect of wildlife. UNSCEAR directly reports to the United Nations General Assembly. So, since in UNSCEAR many member states of the United Nations are participating, this represents a kind of consensus of the UN member states on the effect of ionizing radiation. The third player in this is the IAEA, the International Atomic Energy Agency. Again, the IAEA was also founded in 1957. It was founded also to support member states in the application of nuclear techniques. You may know that in the 50s and 60s, many states of the world have established nuclear programs for both generation of electricity and also for the application of nuclear techniques in science and industry. And to have some standardization and some common goals. The IAEA was founded, and in one of the articles it is said the IAEA should establish safety standards of safety for protection of health and minimization of danger to life and property, and provide for the application of these standards. So the task of the IAEA was to elaborate a set of standards to ensure the safe application of nuclear techniques. Here you have a slide which shows how these three institutions work together. First of all, we have the UNSCEAR, and they provide scientific reports on the radiation effects and also scientific reports on radiation levels from different applications. These reports from UNSCEAR, they are, let us say, digested by the ICRP, and from this ICRP elaborates recommendations on dose limits and on reference levels. Say in which situation which doses are acceptable and which should be tolerable. From all of this, the IAEA produces safety standards for protecting people and the environment. However, the IAEA does it not on their own, but in cooperation with its member states. IAEA has meanwhile about 170 member states. This means nearly any country on the planet is member of the ICRP, of the IAEA. So the IAEA safety standards have different categories. First of all, a very high-level document is the fundamental safety principles. This is, so to say, it gives 10 main overarching objectives for safety with regard to the use and application of ionizing radiation. This is a very thin report, very thin document. It has only 20 or 30 pages. However, to elaborate what does it mean in practice, we have the safety requirements. And those are safety requirements for a range of different applications. Here is the safety requirements for the management of radioactive waste. And once we have the requirements, they define what is the role of the government, what are roles of the regulator, what are roles of operators, etc. Then we need still more information on what does these requirements mean in practice. So whereas the requirement says what to do, what shall we do, the safety guides provide information on how to do it. So, coming back to the safety fundamentals. There are 10 fundamentals, and it defines the responsibility for safety. Who is responsible? What are the role of the government? Then a leadership for the management of safety is necessary. And then we have the three principles of justification of facilities and activities. This means whenever nuclear techniques or nuclear applications are applied, it needs to be justified. It means, has it really a net benefit, and does it more good than harm? And only if this is the case, it is justified to have a specific application. Then we have the optimization of protection. It is obvious that the application of nuclear techniques may cause radiation exposure to people, so protection measures have to be in place to protect people. However, optimization means that the protection measures, the protection measures and the doses avoided due to the protection measures should be balanced. Number 6 is the limitation of risks, and this means it is necessary to put a limit for the risk of individuals. We should also protect future generations. This is also important for construction and operation of facilities for nuclear waste, for the disposal of nuclear waste. Then action should be taken to prevent accidents, and should accidents occur, emergency preparedness measures and an appropriate emergency response should be in place. And number 10 is there may be some radiation risks which cannot be regulated. Nevertheless, also, if possible, there protection actions to reduce existing or unregulated radiation risk should be in place. For radiation protection, the IAEA Basic Safety Standards is a key document. And again, all these standards represent international consensus on radiation protection. And international consensus because all these standards have been developed by the IAEA in cooperation also with other international organizations. In this case, this is the European Union, the Food and Agricultural Organization, the ILO is the International Labour Organization, WHO is the World Health Organization. So all these international organizations contribute to the development of such standards. So that's important. And by the end of the day, all the IAEA, represented by the Board of Governors, as well as these organizations, have to agree to these international standards. So this represents really an international consensus. And to develop such a document is a very long process, because you may imagine if you have all to ask these organizations, ask for input, assimilate the input, and find a consensus on all the opinions which are around. This takes time. Nevertheless, I think due to this procedure of development, these standards have a pretty high weight. The BSS, in particular, defines responsibilities for the government and the regulatory body, as well as for the operator of a nuclear installation. Then it defines exposure situations. Then we had the radiation protection principles and the radiological criteria. And I will go a little bit more detail into this. So the system of radiation protection knows three exposure groups. First is the workers. This means those people who are occupationally exposed during their work. This can be workers in nuclear power plants, but also people who work in laboratories dealing with radionuclides, but also people in the medical area. And we have the patients. This is people who are undergoing treatments, and the general public. And we have three exposure situations: planned exposures, emergency exposures, and exposures from existing contaminations. And we have also the three radiation protection principles: justification, limitation, optimization. Okay, so the exposure groups: occupational exposure is exposure of people, of workers during their work. Public exposure is exposures to members of the public. I mean, this is all people who are not dealing with radioactivity as a consequence of their work. This is anyone due to in plant existing exposure situations and emergency situations. And this excludes any occupational exposure or medical exposure. So this is medical is not including in public exposure. And medical exposure, this is patients undergoing medical or dental diagnosis or treatment, and carers or comforters of patients undergoing radiological procedures, and also volunteers subject to exposure as a part of a program of biomedical research. So the plant exposures is all situations involving the planned introduction and operation of new sources. This means whenever an activity is planned that may expose people living outside the facility, the planned facility, there is a limit, or the people outside the facility shall not be exposed above a certain limit. However, we have also emergency exposure situations which are usually unexpected. This may occur during the operation of a plant exposure, which is a nuclear accident, for example, or any other accident. However, also from a malicious act which requires urgent attention. And finally, we have existing exposure situations. These are situations that already exist when a decision on control has to be taken. Typical example for that is a situation near Fukushima. After the accident, the contamination exists, and actions, it has to be checked whether actions need to be taken to reduce the levels of those in this area. This also includes natural background radiation, for example from radon. There are some areas in the world, on the globe, with very high background level of radon, and the radon levels in houses may be very high and may cause exposures to people which may cause health effects. And also residues from past practices which operated in the past and which were not controlled by the current system of radiation protection. We all know that in the beginning of the nuclear age, radiation protection measures were not fully in place, and at some places environmental contamination still exists, which may cause enhanced levels to people living in this area. And we have also, for example, residues from incidents and accidents. One example is, after the accidents in Chernobyl or in Fukushima, for example, soil was removed or areas were decontaminated, and a lot of waste was generated. And also those residues may cause enhanced levels of exposure to people. And this has to be also covered by within these existing exposure situations. Let's come again to the radiation protection principles. We have the justification. This means any action should be adequate to the risk, and by the end of the day, you should do more good than harm. This sounds easy, but in practice, maybe not so easy. It always requires a case-by-case consideration. For the optimization, an important principle is the ALARA principle. This means that any additional radiation exposure should be as low as reasonably achievable, economic and social factors being taken into account. So this means do as good as you can, but any optimization measures should be also adequate to the risk. And then we have the limitation to make sure that individuals are not exposed at levels higher than the dose limits or the reference levels. And these are two different things. The dose limits is for planned exposures. So this means when something is, a facility is planned and will be constructed and go into operation. In this stage, the exposure is still under control. You can design the facility can be designed as such that those limits will not exceed. And the dose limit from all planned activities must not exceed an effective dose of 1 millisievert per year from all doses. And if you have several sources in an area, the total dose to an individual living in this area should not be higher than 1 millisievert. So if you have two installations, simple case would be depending on the local circumstances, that maybe each of these two facilities has to be designed as such that the maximum dose from one facility is 0.5 millisievert per year. In practice, it's a bit more complex. This is just an example. But we have a limit because we plan something, and we have to plan it as such that there's compliance with the limit. However, if you go for emergency situations or existing exposure situations, I mean, an emergency is an emergency. You cannot plan, and in this case, it does not make sense to give a limit because you don't know what happens. However, for emergency situations, they're giving reference levels. And reference levels, the reference is not a limit, but it's a target. The government or whoever is responsible should take measures that the exposures to people complies with these reference levels. And here also, what you see here, we have a fixed value for the limit. For the reference level, there's a range is recommended. Let's start with the emergency. I mean, for emergencies, the range is from 20 to 100 millisievert. So measures should be taken that people are not exposed at levels higher than 100 millisievert. However, depending on the situation, it might be simple or easy to take measures that people don't get 100, but maybe 50 or 20. So this also means that people should not get higher more than 100, but nevertheless, you should do as good as you can. And if you can achieve 20 millisievert with a justifiable effort, 20 millisievert should be tried to achieved. And the same is for existing exposure situations. The upper bound of the reference level is 20 millisievert, but the lower bound is 1 millisievert per year. The existing exposure situation is a classical for post-accident situation as we have it in Chernobyl or also in Fukushima. And you may remember that Japanese government for Fukushima has recommended in 2011 a long-term goal for the existing exposure of 1 millisievert per year. So they were going towards the lower end of this range. And there's this flexibility is to also be able to check the feasibility of measures and also to take into account the experience which has been made so far in the management of emergency situations or of existing exposure situations. So, what you see here is called the wheel of IAEA safety standards. This wheel also indicates the hierarchical structure of the safety standards. In the middle we have the safety fundamentals. Then within the red ring we have the safety requirements. And here we have a number of different safety guides which provide guidance for a wide range of applications of nuclear, applications. This includes, for example, monitoring of environmental radioactivity, disposal of waste in deep geological formations, disposal of waste for low-level waste, for a number of medical applications. So for many applications you can find guidance on how to ensure safety for a specific application. And it's important to remember that the safety standards are approved by the IAEA Board of Governors, which represent all IAEA member states. Currently, the safety, this series of standards consists of about 130 to 140 standards. The safety guides, which deal with the applications with the safety of applications of ionizing radiation, are re-evaluated every 5 years. So every 5 years it is checked whether this material which has been collected is still actual or whether some revision is needed due to different technological developments, etc. The safety requirements, these are more high-level documents. they are re-evaluated every 10 years. And safety fundamentals, which are very general, overarching objectives, are re-evaluated there's not given a fixed period, but they will also be regularly checked. In addition to that, there is a number of international conventions for safety of nuclear applications. I mean, conventions are agreements between states for the regulation of matters affecting all of them. And this includes the agreements about basic principles or procedures, define common goals, and also have defined duties of participating member states. And finally, they provide a system of exchange of information. This sounds a bit abstract. However, it's, for example, important if you look at member states, neighboring member states. Both of them are applying nuclear applications, maybe nuclear power plants or other things. And therefore, it is necessary, or it might be useful for them, to exchange, to have common views on the goal, and also to exchange information on the specific nuclear facilities. There's a number of conventions which are coordinated by the IAEA. They are coordinated by IAEA, but not run by the IAEA. They are run by the member states who are members of the Joint Convention, for example, for nuclear safety, or for the management of spent fuel and radioactive waste. For example, this convention on management of spent fuel and radioactive waste, the member states meet every 3 years, and then every member state has to report about the amount of radioactive waste in their country, how this radioactive waste is stored, whether the storage is in compliance with the IAEA safety standards. If not, they have to report why it is non-compliance and what they are going to do to ensure compliance on the long term. So there's a much exchange of information and pushing or encouraging all the member states to comply with the safety standards of the IAEA. Another convention is on the early notification of a nuclear accident. This means if there is a nuclear accident in country A, this country A has to inform the member states, and in particular the neighboring member states, about this accident, about the severeness of the accident, and the current status of the facility. And there's also a convention on assistance in case of a nuclear accident or radiological emergency. Furthermore, we have the ESPO Convention. This means it's a convention on the environmental impact assessment in a transboundary context. And this environmental impact assessment includes also radiological impact assessment. The London Convention is on the prevention of marine pollution, of dumping of waste and other matters. in particular of radioactive waste. And the OSPAR Convention particularly deals with the protection of the marine environment of the Northeast Atlantic. The London Convention came up in 1972. Until then, it was still a practice of some member states that low-level and intermediate-level radioactive waste has been dumped in the ocean, in the North Atlantic, but also in the Pacific and other places. And within this convention, it was agreed that this practice should stop, and finally it stopped. Not in 1972, but I think in 1990 something. Okay, a summary. The IAEA safety standards define the radiation protection system. It's important to note that this has been internationally agreed. It is based on science, based on the knowledge on effects of an ionizing radiation, and it includes all relevant exposure situations as planned exposure, emergencies, or existing exposure situations. And very important, the IAEA standards are established by IAEA in consensus with all member states and also with other international organizations. The application of the safety standards is within the national responsibility, so each member state is responsible to implement it, to apply that. And if necessary, IAEA provides support for the application of safety standards. Some countries which have not a long history in the application of nuclear techniques, they might need in the beginning some assistance and some support to implement the standards in their regulations. And as we have seen, the safety standards are complemented by international conventions. Thank you very much. Arigato.